Hey guys, Mr. Backerberg here. In this video we're going to be running through the review for test number 11. Taking a look at problem number 1, we're asked to solve that system by using substitution. So what we want to do is we want to isolate one of our variables. So I'm taking a look at the top equation and I'm going to work on getting y all by itself. So the first thing I'm going to do is subtract that 2x over to the right hand side. So we've got negative y equals negative 2x plus 10. Y still isn't by itself because it's got the negative in front, so I'm going to take everything divided by negative 1. So then we get y equals 2x minus 10. Now what we're going to do with that 2x minus 10 is in our other equation, since that's what y is equal to, we're going to replace the y in our second equation with the 2x minus 10. So we end up getting 3x plus 2 times 2x minus 10 equals 1. We're going to take that 2 and distribute it into the parentheses. So we get 3x plus 4x minus 20 equals 1. If we take the 3x plus the 4x, we get 7x. With this minus 20, we can add that over to the right-hand side right away, so this equals 21. And then if we divide both sides by 7, then we end up getting x equals 3. Now we're not quite done yet because we have to plug that 3 back in. So I'm looking at this equation where we rearranged it to get y equals, and I'm going to plug the 3 in there for our x. So if we take 2 times 3, we get 6, and then 6 minus 10, we end up with a y value of negative 4. And then I'm going to write my answer as an ordered pair. So our x value was 3, our y value was negative 4, so it's the point 3, negative 4. Taking a look at problem number 2, we're asked to solve this system graphically and sketch out the graphs. In order to graph these equations, they need to be in y equals form. The first one is okay, but we need to do a little rearranging with the second one. I'm going to subtract the x over, so we get 2y equals negative x plus 6. Divide everything by 2, and we end up getting y equals negative 1/2 x plus 3. I'm going to plot out that equation first. That's a linear equation, so we can look at our y-intercept and our slope. That's a linear equation, so it's in y equals mx plus b form. The 3 on the end is our y-intercept, so I'm going to go up 3 spaces, put a dot. The slope is negative 1/2, so I'm going to go down 1 over 2, and I'm going to do that a bunch of times to get points plotted out. Now with our second equation, we may want to make ourselves an x and y chart in order to get some points to plot out. If we plug in negative 4 for our x, we end up getting 4 as our y value. So we'll plot that point, go left 4 spaces and up 4 spaces. If we plug in negative 2 for our x value, we'll get negative 2 as our y value, so we're going to go left 2, down 2. If we plug in 0, we're going to get negative 4. So this is like the left half of our parabola. On the other side, if we plug in 2, we're going to get negative 2. And if we plug in 4, we're going to get 4. So we've got those points plotted out. I'm going to draw in our lines. So there is our graph for our linear equation and for our parabola. Now that doesn't really give us an exact place or places where these lines intersect. So I'm going to graph these out on my calculator as well. For our first equation, we had a half x squared, so I'm going to go 0.5 x squared minus 4. And for our other equation, we had negative a half, so I'm going to go negative 0.5 x plus 3. So if we graph those out, here are our two lines. Now, as we're looking at these lines, we want to figure out where they're intersecting. So I'm going to hit second trace, and option number 5 is intersect. Now we're going to have to do this 2 times because we've got 2 intersection points with our lines. So for our first one, I'm going to focus on that left intersection point. So I'm going to arrow over left to get closer to this intersection point. So here I'm just to the left of my intersection point. It asks us, are we on our first curve? So I'm going to hit enter because we were on our blue graph. Now I'm on the red graph, so I'm going to hit enter. Takes a guess, but we don't have to. We can just hit enter one more time. So our first intersection point happens at negative 4.27 and 5.14 if we were to do a little rounding there. But then we have to do the same thing with the other point. So hit second trace again. Option number 5 is intersect. Arrow over closer to the other intersection point this time. So now we're just to the right of that intersection point. We're on our blue curve, so I'm going to hit enter. We're on the red line, so hit enter. And one more time. We end up at 3.27 and 1.36. So those are our two intersection points of our graph. In number 3, we've got a little bit of a word problem. We're setting up a business selling widgets. We make an initial investment of $32,000. Now the unit cost to produce our widgets, it's $2.35 per widget, and we can sell those things for $5.95. So what we want to figure out is how many widgets we need to sell in order to break even. So what we're going to be looking at is we're going to be looking at some costs and some revenues. So first, let's look at the money that we're spending. Let's look at our costs. We were told that it costs us $2.35 for every widget that we make. So that's going to be 2.35x because we're spending $2.35 each time we make one of these things. But we also had our initial investment of $32,000. That's also money that we spent. So our cost function is this C equation. Now if we're looking at revenue, money that we're bringing in, we're selling these widgets for $5.95 a piece. So that's going to be 5.95x. Now as far as a break-even point, break-even means that our costs and our revenues are equal to each other. So I'm going to take these two equations that we just wrote out and set them equal to each other. So 2.35 plus 32,000 equals our 5.95x. Now I'm going to subtract the 2.35x over to the right-hand side. We end up with 32,000 equals $3.60 x. We need to divide both sides by 3.60. Now we end up with x equals 8,888.9, but we can't sell 0.9 of a widget, so we're going to round this up to the nearest whole unit. So that's going to be 8,889 widgets or units sold in order to break even. Taking a look at problem number 4, we're given a system of equations and asked to solve it using Gaussian elimination. So our goal is to get this in row echelon form. So we look at our top equation and we need to check, does it lead off with just a plain x? And the answer is yes, it does. So that equation is okay to use as the first equation in our new row echelon system. Now for our second equation, we want to have just y's in it. We have to eliminate the x. So what I'm going to do is I'm going to work with that second equation, the 2x plus y minus z equals 0, and we need to get rid of those two x's. So I'm going to take our top equation times negative 2. So we get negative 2x plus 2y minus 4z equals 6. Then if we add these together, the x's cancel out. We've got 3y minus 5z equals 6. We need our y to have a 1 in front of it, so we're going to divide everything by 3. So our new equation that we're going to fill into our new system that we're building is y minus 5/3 z equals 2. So now we've used our top two equations, so we're moving on to our bottom equation, the negative x plus 2y minus 3z equals 7. First thing we need to get rid of is that negative x in the front. So I'm going to take that top equation as is because it already has a positive x. So x minus y plus 2z equals negative 3. Add these up, the x's cancel. We get y minus z equals 4. Now we need to get rid of that y, so I'm going to grab our new second equation but multiply everything by negative 1. So we get negative y plus 5/3 z equals negative 2. Adding these up, the y's cancel out. Negative z plus 5/3 z, we end up getting 2/3 z equals 2. Now we need to get rid of this 2/3 that's in front of our z, so I'm going to divide everything by 2/3, and when we do that, we end up getting z equals 3. Now from there, we need to work backwards in order to figure out what our y value is, so we're going to take the 3 and plug it into our next equation up. So we'll have y minus 5/3, plug in the 3 here, equals 2. Now these 3's are going to cancel out, so we've got y minus 5 equals 2. We'll have to add the 5 over to the right-hand side, so we end up with a y value of 7. Then we need to go all the way up to our top equation, fill in our y value and our z value. So we've got x minus 7 plus 2 times 3 equals negative 3. Well, 2 times 3 is 6, and if we combine that with the negative 7, we get x minus 1 equals negative 3. Add the 1 over to the other side, and we get x equals negative 2. Now I'm going to write my answer as an ordered triple. So we've got negative 2 as our x value, 7 as our y value, and 3 as our z value. So that ordered triple is our answer. In problem number 5, we're given a non-square system of equations and asked to solve it. So we're going to work on getting this in row echelon form. The top equation already leads off with a plane x, so we're just going to use that equation as is. So we've got x minus 2y plus 5z equals 2. For our second equation, we need to get rid of those 4 x's. So I'm going to take this first equation times negative 4. So we get negative 4x plus 8y minus 20z equals negative 8. Now if we add these together, the x's cancel out. We've got 8y minus 21z equals negative 8. And I'm going to divide everything by 8 because we want to have a 1 in front of the y. So we get y minus 21/8 z equals negative 1. Now we don't have a third equation to work on getting z all by itself. So we've got nothing to restrict z down. So in a non-square system, what we're going to do is we're going to say that z can be any number. So z can be a. Now I'm going to erase this stuff so I have a little bit more room to work, because now what we need to do is plug that a back in to find our y value and our x value. So if we go to our next equation up and fill in the a for our z value, we've got y minus 21/8a equals negative 1. I'm going to add that 21/8 a over to the other side, so we get y equals 21/8 a minus 1. And now we need to work on figuring out what x is. So in this top equation, we're going to need to fill in our y value and our z value. So we've got x minus 2 times our y value, which is 21/8 a minus 1. And then we've got plus 5 times our z value, which is just going to be a, equals 2. Now with this negative 2 outside of our parentheses, I'm going to distribute that into the parentheses. So we get x. Now taking negative 2 times 21/8, we can do a little reducing there, and we end up getting negative 21/4a. And then if we take negative 2 times negative 1, we get plus 2. And then we've got our plus 5a on the end, and this equals 2. Now I'm going to subtract the 2 over to the right-hand side, so this 2 will cancel out with the other 2. We can combine like terms with this negative 21/4a and this 5a. So we end up getting x minus 1/4a equals 0. So if we add the 1/4a over to the right-hand side, we get x equals 1/4a. Taking a look at number 6, we've got another word problem. So we've got a coffee manufacturer selling 10-pound boxes of coffee for $26. The boxes contain 3 different flavors. We've got vanilla for $2 a pound, hazelnut for $2.50 a pound, and mocha flavored for $3 a pound. Now we're also told that the box contains the same amount of hazelnut and mocha flavored coffees. We want to set up a system of equations to figure out how many pounds of each type of coffee are in this box. So we need to read into this a little bit. We're told that we've got 3 different kinds of coffee, and altogether we've got 10 pounds. So I'm going to use some variables to represent these things. I'm going to use V for vanilla, I'm going to use H for hazelnut, and I'm going to use M for mocha. So when we take the amount of vanilla plus the amount of hazelnut plus the amount of mocha, we've got a total of 10 pounds. Now if we look at costs, vanilla costs $2 a pound, so I'm going to take 2 times V, plus hazelnut is $2.50 a pound, so 2.5 H, and our mocha is $3 a pound, so 3M. And when we add up that total cost, this box costs $26. Now for our last equation, we're told that the box has the same amount of hazelnut and mocha. So the H value is the same as the M value. Those things are the same. But as we're setting up this system, we want to have our variables on the same side. So I'm going to subtract that M over to the left-hand side, and that'll be our last equation in our system. So H minus M equals 0. Now we're going to work on getting this in row echelon form. I'm going to erase this just so I have a little bit more room to work. In row echelon form, we want our top equation to lead off with a 1 in front of our V. So this top equation is okay to use as it is. So I'm going to go V plus H plus M equals 10. Now for our second equation, we don't want to have any V variables, and we want to lead off with a 1 in front of our H. So I'm looking at this bottom equation. It fits what we need it to. It doesn't have any V variables, and it has a 1 in front of the H. So I'm going to fill that in as our new second equation. But we're going to have to do a little bit of work with this 2V equation, doing some elimination stuff. So 2V plus 2.5H plus 3m equals 26. First thing I'm going to do is work on getting rid of those two v's. So I'm going to take our top equation here times -2. So we get -2v minus 2h minus 2m equals -20. Add these up, the v's cancel out. We've got 0.5h plus m equals 6. Now we're looking at getting rid of h next. So I'm going to take this h equation right here in the middle and multiply it by -0.5. So we get -0.5h plus 0.5m equals 0. Add these up and the h's cancel out. We've got 1.5m equals 6. Divide both sides by 1.5 and our m value is 4. Now we can work backwards. Plug that 4 into the next equation up, so we get h minus 4 equals 0. We have to add that 4 over to the other side, so we get h equals 4. And then if we plug the 4's into our top equation, v plus 4 equals 10. 4 plus 4 is 8. We would have to subtract that over to the right-hand side, so v equals 2. So we've got 4 pounds of mocha, 4 pounds of hazelnut, and 2 pounds of vanilla. In number 7, we're going to look at setting up our partial fraction decomposition, but we are not going to solve for our constants. So as we're looking at this rational expression, the first thing we want to do is factor out the bottom. So first thing I see happening is we can pull out a GCF of x. So we get x times x squared minus 9. But then I notice that we can do a little bit more factoring with the bottom. The x squared minus 9 is a difference of perfect squares. So we can split that up into x plus 3 and x minus 3. Now that we have our denominator completely factored out, we want to start splitting up our fractions. So our first fraction is going to get x on the bottom. Our second fraction is going to get the x plus 3 on the bottom. And our last fraction is going to get the x minus 3. Now on top of each one of these, we're going to get just a plain constant since we don't have any quadratic terms. So on top of the x, we'll put an a, then we'll go b, then we'll go c. So that is our partial fraction setup, but we are not going to solve for a, b, and c, so that is our final answer. Now number 8, when we do our partial fraction decomposition, we are actually going to solve for the constants on this one. Nice thing about this one though is the denominator is already factored out, so we can just start splitting this up. So we've got x and x squared plus 1. On top of the x goes an a since it's just a first power to x. On top of this one, though, we've got a quadratic term on bottom, so we're going to have to fill in a bx plus c on top of that one. Now, what we're looking at doing is canceling out all of these denominators, so we're going to multiply both sides by x and x squared plus 1 to get the denominator on the left to cancel out, and whatever we do to one side of the equation, we'll have to do to the other side of the equation, so we're also going to multiply by the x and x squared plus 1. The left-hand side of our equation now just says x squared minus 1. On the right-hand side, if we were to take this a fraction times the x and the x squared plus 1, the x's would cancel each other out. We would still have the a left over, and the x squared plus 1 would be left over as well. For the second fraction, if we were to multiply that by our x and x squared plus 1, this time the x squared plus 1s would cancel each other out. We'd still have the bx plus c, and I'm going to put that stuff in parentheses because we need to still multiply that by our x. Now there's a little distributive property that we need to do with our a and with this x on the right hand side. So we end up with x squared minus 1 equals ax squared plus a plus bx squared plus cx. And now we're going to look at setting up our equations. So first I want to deal with the things that have x squareds in them. So on the left hand side we just have 1x squared. On the right hand side we have ax squared plus bx squared. But then I'm going to drop all of the x squareds. So then on the left we have 1 equals a plus b. Next thing I'm going to look at is our first powered x terms. So on the left hand side there aren't any x's, so we've got 0x equals. On the right hand side we've just got cx. So if we drop the x's, we get 0 equals c. Next thing we need to look at is our plain constants that don't have any x's in them. So on the left-hand side, we have -1, and on the right-hand side, we have a. So a is -1. We still don't know what our b value is. So we need to go up to our top equation, plug in our -1 for the a. I would take that -1 and add it over to the right-hand side, so we end up with a b value of 2. So we've got an a value of -1, a b value of 2, and a c value of 0. So now we're going to go back up to where we broke down our partial fractions, and we need to fill in our a, b, and c values. So in that first fraction where we've got a over x, we need to fill in our -1, so -1 over x plus our b value is 2, so we've got 2x. Since our c value is 0, we don't really need to put the plus 0 on the end, so it's just 2x over x squared plus 1. So this is our partial fraction decomposition. Taking a look at problem number 9, we're asked to graph out these inequalities and label the intersection points between the inequalities. I'm going to take a look at this first inequality. We want to get y all by itself in order to graph this one out, so I'm going to subtract the x over, so we get 2y is less than -x plus 6. Divide everything by 2, and we end up with y is less than -1/2 x plus 3. I'm going to plot that one out first. We've got sort of like a y equals mx plus b linear. So I'm going to go up 3 spaces first because that's our b value, put a dot. Our slope is -1/2, so I'm going to go down 1 over 2, put a dot there, down 1 over 2, down 1 over 2. And I'm going to do this a bunch of times to figure out what our line should look like. Now, as we're drawing in this line, this does not have the equals to line underneath it. So I'm just going to draw in a dotted line to represent that inequality. I'm going to hold off on shading this. I'm going to wait till we get all 3 of our inequalities plotted out to do our shading. So our next one says x is greater than or equal to -2. Well, since we've got kind of like an x equals equation, that's going to be a vertical straight up and down line through the x value of -2. And this one's going to get a solid line because we do have that equals to portion of our inequality. For our next one, we've got y is greater than or equal to 0, so we're going to have a flat horizontal line through the y value of 0, and again a solid line because we've got that equals to portion. Now as we're looking at figuring out where we want to shade, we could plug in a test value. So for this first one, our line does not go through 0, 0, so we can plug 0 in for our x and y. So this would say 0 is less than 3. So this is true. So underneath this dotted line, we want to shade towards 0. So as we're looking at shading this, we're going to be below this dotted line. So we're going to fill in this triangular portion. Now I'm going to stop and think once I hit this vertical up and down line at -2. It says that our x value has to be greater than -2, so I don't want to go past that at all. And also if we look at this, we're bounded by this y is greater than or equal to 0. Since we want our y values to be greater than 0, we have to be above that line. So the only portion of this that's going to get shaded is that triangular region between all 3 of our lines. But now we were also asked to label our 3 intersection points. So I'm going to start with this point right here. That is the point -2, 4. If we look at this point down here where our 2 solid lines intersect, that's the point -2, 0. And if we look on the far right hand side, that's the point 6, 0. So those are our points of intersection between our inequalities. That's going to be it for this video. Thanks for watching.